right, today we're going to review polynomial rational inequalities. This is something we did learn in Algebra 2 out of its new trace, so it shouldn't be new. We'll start with just polynomials. Write in as a standard form equation. So that means we need to get everything on the same side. So I'm going to work this problem at the same time. So minus 12. So we have x squared minus x minus 12 is greater than 0. Now, to work the problem out, I'm just going to think of it as an equation, but when I go to looking at the intervals, I am going to come back to this. It has to be greater than 0, or it has to be positive. So we'll be looking for things that are positive. So looking at this problem, my next step is to find the zeros. So if I'm looking for factors of 12 that will add to give me -1, that's going to be x minus 4. And x plus 3. I'm sorry, I should have meant to be looking at this as an equation at this point. So I have two solutions. I have 4 and -3. And that's going to help me set up my interval. So I'm going to draw a number line next and label those zeros, because that's going to set up my intervals. Here I have a number line, and -3, and then I have 4. So these are the 3 intervals I need to test. So I'm going to test each interval. So what does that mean? Well, I'm looking at the interval from -infinity to -3. I need to pick a point there to test in the equation. I'm going to test -4. So I plug a -4 in. -4 squared is 16. Minus a -4, which would be plus 4, and then minus 12, and that's going to give me 20 minus 12, and it's going to give me something. Let's see. You really don't have to go through the whole process of figuring out what it gives you. You just have to decide if it's positive or negative. So in this section, we're positive. Then let's test this next interval. So between -3 and 4, I'm going to test an easy point. Between -3 and 4, I'm going to test 0. That's the easiest one to test anyway. So I get 0 squared, which is 0, minus 0, minus 12. So that's going to be a negative interval there, or negative values. And then I test in this upper 4 to infinity. I'm just going to pick 5. So that's with 5. And that's going to be 25. Minus 5 minus 12, which is 20 minus 12, which is also going to be positive. Now, according to my original problem, I'm looking for where it's greater than 0, so my solution is going to be the positive intervals. So my solution for this is -infinity to -3, union with 4 to infinity. And it is not going to be equal to, because this doesn't have an equals to. So then you write the solution in interval notation. Now we're going to work 3 examples, just to give you some additional practice. So looking at this example 1, I'm going to add 5x to both sides. So I have x squared plus 5x is greater than 0. I'm going to write it as an equation just to simplify it. I'm going to keep this in mind. Again, I'm looking for positive regions on this one, not negative regions. So this is going to factor out an x, and I get x plus 5. So that's going to help me set up my intervals, because I know my solutions are 0 and -1. So thinking about my number line, I'll erase this over here. I have a number line, -5, 0. I'm going to test 3 intervals. That's where I'm looking to see where this holds true. So I'm going to test -5, or -infinity to -5 interval. So I'm just going to plug in. I'm going to just plug in a -6. Plug that in, -6 squared is 36. And then 5 times a negative is going to be -30. So this is 6. So that's a positive region. Then I'm I'm going to test this region right here, the -5 to 0 region. So I'll go with -1. We have -1. We'll see what that is. That's going to be 1 minus 5. So that's going to be a -4. So that's a negative region. Positive and a negative. And I'm going to check from 0 to infinity. And I'll use 1. Why not? That's pretty easy. So that's going to be 1 plus 5, which is 6. So that's a positive region. So my inequalities are greater than 0, so I'm looking for positive areas. There, there. So my solutions will fall in negative infinity to -5, unions with 0 to infinity. So that's what you do. You solve, factor solve, come up with your test regions, and then check it. Let's try the next one. I'm going to have to erase here. So we're going to get everything on the same side. So x squared plus 2x minus 1 is going to be less than 0. This time we're looking for negative regions. Trying to factor that's not going to work, so I'm going to have to use the quadratic formula. Negative b is a -2 plus or minus the square root of b squared, which is 4, minus 4 times a times c, all over 2 times a, which is 1. So -2 plus or minus the square root of 8 over 2, -2 plus or minus 2 square roots of 2 over 2, so that simplifies to -2 plus or minus square root of 2, -1. So that gives me my two solutions. -1 minus the square root of 2, and -1 plus the square root of 2. You probably have to use your calculator to figure out what that means. I do know, looking at my number line, -2, -0. The first one is a little bit below -2. And then this one is a little bit above 0. It's not quite at 1, and this one's not quite at -3. So these are my test regions. So if I'm testing here, I'll test with from negative infinity, this region, negative infinity, -1 minus square root of 2. That's my test region. And it wasn't an equals to, so I don't need to worry about that. And we're plugging in -3. So after the -3, and that's going to give me 9 minus 6 minus 1, which is 3 minus 1, which is 2. So make sure I get that right. Okay, so that's a positive there. Now looking at this middle region, I'm going to go with something easy, 0. I like to know that. So f of 0 is going to be -1, so that's a negative region. And I'll try something up there, probably just 1. Right, f over 1. And then that gives me 1 plus 2 minus 1, that's 3 minus 1, that's 2. So that's a positive region. But here's what's important here, I'm looking for negatives because that's less than. So the only region that's going to be a solution is right here. And what is that region? From -1 minus the square root of 2 up to -1 plus the square root of 2. That's where my solutions will fall. And that's why we reviewed all of the factoring techniques. We're going to need it. All right, and then this third problem, before we do the rationals, minus 10x. So we have x to the third minus 3x squared minus 10x is greater than or equal to 0. So this one we're going to be careful with that equals. Factoring, we'll factor out of x. So we get x squared minus 3x minus 10 is greater than or equal to 0. Then I want to factor this minus 5, and x plus 2. And we'll say equal to the solving. So we're looking for 0, 5, and -2. So we've got a couple test regions here. We've drawn our number line. We actually have 4 this time. -2, 0, 5. And we need to test from -2 to, or from -infinity to -2. We need to test from -2 to 0. We need to test from 0 to 5. And then 5 to infinity. Alright, so we'll try the f of a -3. Plugging that in, we end up getting -14, I think, when you do that. So that's a negative region. For the next one, I'm going to plug in a -1. I'm going to plug that in. I end up getting 0, 10. Get 10 for that. Well, -1 minus 3 plus 10. So that's going to be positive. So it's going to be a positive region. Like I said, you don't even have to worry about exactly what the value is. Plug in for this region, I'll plug in a 1. When I plug in a 1, I get a -1. I get 1 minus 3 minus 10. That's going to end up being negative. And then in the last region, I'll plug in a 6. And when I plug in a 6, I end up getting 48. So I am looking for greater regions. So here, 48 is positive. So here, so those are my regions. -2 to 0. Unions with 5 to 8. But here's where I have to be careful. Are any of these going to be equal to 0? So if I plug in a 5, up here, I get 125 minus 75 minus 50. You can see that's going to be 0. If I try 0, yeah, 0 is going to be 0. I can see that. That's easy. And if I plug in a -2, I get a -8 minus 24 plus 20. That's right. That should be minus 12. Yes, and that ends up being 0. So that also. Now, when we start looking at rationals, same idea. You're going to write in standard form. This one's already written in standard form. You're going to simplify and factor if you can. So this is x minus 3 over x plus 2, x minus 2. Then I'm going to look for the denominator, the values that would make my numerator denominator 0. So I have a couple. At the top, what would make that 0 would be 3. So that's going to be one of my areas I need to be checking. And on the denominator, I'm going to have -2 and 2. And then I draw the number line, label these values. Test each interval, and write an interval notation. Make solution. The number line, this one has a lot of test areas. Make it 2, 2, 3. So we've got 4 test areas. And when I test, I plug in a value, test each one. This one was negative. This is positive. This one's negative, and this one's positive. We can just plug values in that region, just like we did on the front. So we end up getting 2 regions at work, because we're looking for positives, so -2 to 2. I'm going to test those values to see if any of those equal 0. They don't. So, and then 3. So again, plug in f of a -2, see if that value is included. Number 1. We are going to move 3 over. Then we have to simplify that. Clean it up a little bit. We have a -2x minus 6 over x plus 2, and we'll get equal to 0. So when would we get something that's 0 or undefined? We have to check those undefined points. If we set that equals 0, so I'll set that equal to 0, so we get -2 and -3. So looking at our number line, -3, -2. This time we only have 3 test regions. Little test points in there. So we'll try the f of -4. When we plug that in, we end up getting something that is negative. And we check this region, probably with a fraction, probably best to use your calculator, -2.5. Plug that in, and we get a positive value out. And then we'll test this other region with -3. When we do that, we end up getting a negative value. And again, I kind of just look at it, and I'm like, oh, -3 over -3 plus 2. I can see there's going to be a negative over a negative, so that's going to be a positive. But then I have, so that's going to be a positive, and then we'll do -3. And, you know, if you have to look at specifically the value you want to, it's going to be 3 minus 3, which is equal to 0. So that is going to be in our solution region. All right. The rest of them is going to be less than 0. So we have 2 solution regions. There's less than 0, because that's what it says, less than. So negative infinity and -3. We have to check -3, and then union to it. I see my mistake there. I tested -3. I figure out when it was working out. I should have been testing 3, something bigger, maybe 0. There's 0 over there. 0 over 0 plus 2. That would give me 0. 0 minus 3 would be a negative. Oh, that wasn't something that was 0. And then we have -2 to infinity. And then we just checked -3 accidentally, so we went back to the same. All right, then the last one, a little bit more complicated. Remember, you can't cross multiply with inequalities. You're going to move the thing over. Minus this whole thing. And then, you know, our denominator is going to end up being x plus 1, x plus 3, and then we have to multiply. We end up with kind of a big mess up top, but you know, it ends up to be x plus 17. Remember, you have to distribute this negative, and then you're going to multiply this by x plus 1, this by x plus 1. You learn all that. And then this one by x plus 3, and this by x plus 3. Which looks like a big old mess, but it ends up cleaning up nice. And this is greater than or equal to 0. So we have 3 test values. What makes this equal to 0? -17. And then what makes that? -1 and -3. So negative 17, negative 1, or negative 3 to negative 1. When you test those regions, 4 regions to test, instead of being negative, positive, negative, positive. So we know that this one was a greater than, so we're looking for positive regions here and here. So from negative 17 to negative 3, and then from negative 1 to infinity, testing the values, the only one that ends up giving you 0 is 7. Now what happens if we look at the graph? We'll write in standard form, which is, this is what we did a couple classes ago. Look for any asymptotes, and then find your intercepts. And we'll go through this kind of quick. So this is the same problem as number 1, so we know that it was negative 2x minus 6 over x plus 2. It's less than or equal to 0. So we have a vertical asymptote at x equals a negative 2. We have a horizontal one at y equals a negative 2. We have no slants, no holes. So we know that we have this and this. And then when we find our intercepts, our x-intercept is x is equal to a negative 3. A negative 3 right here. And then is that 0? Or is that negative? This is what it's equal to. So if we think about it graphically, what it means, it's saying to look for areas where this is less than 0, but 0 is a line. 0 is this axis right here. So where is it less than 0? In this area, negative infinity to negative 3. And here, in that area, which is negative 2 to infinity. And because that was a 0, we know that was. That's how it